we want to find the exact trig function values using the unit circle. The great thing about the unit circle is that if we sketch the angle in standard position, the point where the terminal side intersects the unit circle gives us both the cosine function value and the sine function value. The x-coordinate is equal to cosine theta, and the y-coordinate is equal to sine theta. So to find the exact value of cosine 5 pi over 6 on the unit circle, we'll sketch 5 pi over 6 radians in standard position, and then determine where the terminal side intersects the unit circle. So the initial side is along the positive x-axis, and now we'll rotate counterclockwise 5 pi over 6 radians. So we would rotate from here to here. So here's the terminal side of 5 pi over 6 radians. Notice how the x-coordinate is equal to negative square root 3 divided by 2, and the y-coordinate is equal to positive 1/2. Because we're looking for the cosine function value, we want the x-coordinate. Therefore, cosine 5 pi over 6 is equal to negative square root 3 divided by 2. Now this one was pretty straightforward because notice how 5 pi over 6 radians was labeled on the unit circle, but I also want to discuss a method for finding this point if this angle was not labeled on the unit circle. As long as you remember that half a rotation counterclockwise would be pi radians, we should still be able to find 5 pi over 6 radians on the unit circle if we divide pi radians into 6 equal parts, because our angle is a multiple of pi over 6 radians. So if we start here and stop here, that would be pi radians. To divide this into 6 equal parts, we'll first cut it in half. That would be pi over 2 radians. And now we'll divide the first quadrant into 3 equal pieces, and then the second quadrant into 3 equal pieces. So in the first quadrant, we'll divide here and here. Now the first quadrant is divided into increments of pi over 6 radians. And now we'll do the same in the second quadrant, here and here. Now that it's divided into increments of pi over 6 radians, we can count by pi over 6 radians. So here's 1 pi over 6 radians, 2 pi over 6 radians, 3 pi over 6 radians, 4 pi over 6 radians, and then finally 5 pi over 6 radians. So this would be another way to find the correct point on the unit circle to determine the trig function value. This will be much more helpful in the second example because we're not going to find negative 4 pi over 3 radians labeled on the unit circle. So let's go ahead and try the second example. We want to find sine negative 4 pi divided by 3. So here's the initial side of the angle. And now because the angle is negative, we want to rotate 4 pi over 3 radians clockwise. So again, as long as we recognize that if we rotate clockwise half a rotation, this would be negative pi radians. But because our angle is a multiple of pi over 3 radians, we want to divide negative pi radians into 3 equal pieces. So we're starting here and stopping here, and now we'll divide this into 3 equal pieces. So we'll divide it here and here. So now we could count by negative pi over 3 radians, but because we have negative 4 pi over 3 radians, let's also do the same for the other half of the unit circle. So we would divide it here and here. Now that the unit circle is divided into increments of pi over 3 radians, we can easily count by negative pi over 3 radians to determine the terminal side of this angle. This would be negative 1 pi over 3 radians, negative 2 pi over 3 radians, negative 3 pi over 3 radians, and then finally negative 4 pi over 3 radians. So this will be the terminal side of our angle. Notice how it's also coterminal with 2 pi over 3 radians. And here's the point where the terminal side intersects a unit circle. The x-coordinate is negative 1/2. The y-coordinate is square root 3 divided by 2. Because we're looking for the sine function value, this is equal to positive square root 3 divided by 2. So when first learning how to do this, I realized it can be challenging to find the terminal side of the angle, especially when the angle is not labeled on the unit circle. So we will take a look at some more examples in the next video. I hope this was helpful.